So continuing with this analysis, now steps 7 through 10. We ended on step 6 rather abruptly. Domain intervals for positive and negative. We're really just looking at the x-axis. Anything above the x-axis is a positive interval. Anything below the x-axis is where the function is negative. So again, for this, we identify the zeros and go from there. And we had said that this function is negative for x's that are that go from negative infinity all the way to negative 1.16. And then the function is positive. And I think I erroneously said negative 1.1. I shouldn't have done that. All right. And the function is positive from negative 1.162 all the way to x's that are positive infinity. This function never dips below the x-axis at any point after that zero. We actually already used the turning points. All right, there's an actual name for these. These are local. This is a local maximum and a local minimum, so that's important to note. And the turning points help us with the intervals, distinguish between the intervals that are increasing and decreasing. Anytime you have a turning point, that basically means you're going from increasing to decreasing or from decreasing to increasing. You're changing direction. All right. 8, end behavior. We talked about this briefly in the introductory video, but for end behavior, basically the left goes down, the right goes up. All right. But we need to write that in correct mathematical terms. So we're going to say as x goes to negative infinity, f of x goes to positive infinity. All right. We're going to follow that statement up with the right end behavior. And that's as x goes to positive infinity, f of x also goes to positive infinity. So as the x's get larger, the y's get larger. All right. That's your end behavior. 9 and 10 are actually some pretty simple steps. We're looking at sort of the makeup of this equation. So step 9 asks you, what's the degree of this function? The degree is 3. This is a third degree polynomial. And this is an important piece for you to go back and look at some of the information that you found. It's a degree 3 polynomial. It has 2 turning points, opposite end behavior, and actually only 1 0. So that's something to note. A third degree polynomial could have up to 3 real zeros. All right. And last part that we're looking at, leading coefficient. This is just some terminology. Not so important as far as solving problems, but the leading coefficient is 7. All right. And that is because this is a third degree polynomial, and 7x cubed is the term that contains the leading coefficient. That is 7. Okay. So that's that. That is a complete analysis of a polynomial. There is a second example that you can check out. You can analyze with the same 10 steps, the function x squared plus 4x plus 3. You'll find some things are similar and some things are different. And the main culprit of that is the degree. All right, you're going to find with polynomials, the degree makes all the difference in the rest of the information that we come to analyze. So that is a little bit of analyzing a polynomial.